Breaking barriers, China's $1.5 billion investment in supersonic technology aims to surpass Concorde's speed records. On March 30, 2025, China announced a bold leap into the realm of supersonic aviation with a monumental investment of $1.5 billion aimed at developing a new commercial jet, the C949, that aspires not only to revive but to surpass the speed records set by the legendary Concorde. This initiative, led by the state-owned aircraft manufacturer Comac, signals a significant milestone in the ongoing competition in the aerospace sector, particularly between the United States and China. The C949, a new era in supersonic travel. The C949 is designed to achieve a cruising speed of 1.6 times the speed of sound, Mach 1.6, allowing it to cover distances of up to 6,800 miles, which is a remarkable 50% increase over the Concorde's maximum range of 4,500 miles. This capability opens up new non-stop routes such as from London to Malaysia, promising to drastically cut travel times for long-haul flights. One of the most significant advancements the C949 boasts is its reduced noise pollution compared to the Concorde. While the Concorde's sonic booms registered around 105 decibels, the C949 aims to limit its sonic booms to approximately 89.3 decibels. Engineers attribute this reduction to a revolutionary reverse camber fuselage design that effectively dissipates shock waves, minimizing the disruptive noise typically associated with supersonic flight. Additionally, the aircraft's development includes cutting-edge technology such as an advanced fly-by-wire system powered by artificial intelligence to manage aerodynamic stability. This innovative approach not only enhances performance but also ensures safety at high speeds. Passenger experience and market potential. With a passenger capacity of 168, the C949 is designed to accommodate more travelers than the Concorde, which could only seat 128. This capacity increase is critical for commercial viability, as the market for supersonic travel is projected to reach approximately 45 million passengers annually, representing about 1% of total global air travel. However, the C949 is slower than its predecessor, which could reach speeds of Mach 2.2, enabling transatlantic flights in under 3 hours. Critics may point out this limitation, but Comac's focus on increasing range and reducing noise may ultimately appeal to a broader market. Competing technologies and global implications. The announcement of the C949 is part of a larger global resurgence in interest in supersonic travel, which had waned after the retirement of the Concorde in 2003 following a tragic crash in Paris. Competing with Comac are several American companies, including Boom Supersonic, which has successfully conducted test flights of its XB-1 prototype, achieving speeds of 850 miles per hour. Spike Aerospace is also developing a 1.6 Mach passenger jet, while NASA and Lockheed Martin are collaborating on the X-59, targeting a sonic boom of just 75 decibels. The renewed interest in supersonic travel raises vital concerns regarding the dual use of aviation technology, particularly in a geopolitical context. The potential military applications of supersonic technology could exacerbate existing tensions, especially given that Comac has faced U.S. sanctions due to its connections to the People's Liberation Army, another player in the supersonic race. In addition to Comac's C949, another Chinese company, Space Transportation, recently announced the successful test flight of its Yunqing prototype jet, which is capable of reaching Mach 4, twice the speed of the Concorde. This aircraft aims to enter service by 2027, further demonstrating China's ambitious plans in the field of supersonic travel. Future prospects and challenges. As of March 2025, Comac's ambitions extend beyond the C949. The company has outlined a timeline that includes several key projects such as the C929 slated for 2027 and the C939, expected by 2039. These projects reflect a broader vision that encompasses advancements in both commercial aviation and potential military applications. However, challenges remain. The aviation industry is still grappling with environmental concerns, regulatory barriers, and the economic viability of supersonic travel. The C949's success will hinge on its ability to navigate these hurdles while delivering a product that meets consumer demands and regulatory standards. Conclusion: China's $1.5 billion investment in supersonic technology marks a pivotal moment in the aviation industry. The C949, with its promises of speed, range, and reduced noise, could redefine air travel while also sparking renewed competition on a global scale. As various companies across the world race to develop their own supersonic solutions, the future of air travel may soon be transformed, ushering in a new era characterized by faster, more efficient, and potentially quieter travel. The implications of this technological advancement extend beyond mere convenience. They touch upon international relations, economic power dynamics, and the environmental impact of aviation, making the outcome of this race one to watch closely in the coming years. In examining China's $1.5 billion investment in supersonic technology, particularly its plans for the C949 aircraft, several counterintuitive aspects emerge from the anticipated advancements and the competitive landscape. 1. Slower speed yet greater range. One might expect that a new supersonic aircraft would aim to exceed the record speeds of the Concorde, which could reach Mach 2.2. However, the C949 is designed to fly at Mach 1.6, which is significantly slower than the Concorde. This counterintuitive strategy focuses instead on enhancing the aircraft's range to 6,800 miles, a 50% increase over the Concorde, allowing for non-stop flights on longer routes. This prioritization of range over speed suggests a shift in market demand, where passengers may prefer greater distances without stops rather than shorter flight times. 2. Quieter aircraft with increased capacity. The C949 is engineered to produce sonic booms at approximately 89.3 decibels, which is substantially quieter than the Concorde's 105 decibels. While one might assume that advancements in speed would come with increased noise, this design emphasizes reducing noise pollution to allow for more flexible flight paths, especially over land. Additionally, the aircraft's capacity of 168 passengers surpasses the Concorde's 128, indicating that more passengers can travel at a slower speed with less noise, which may appeal to airlines seeking profitability through increased capacity rather than just speed. 3. Technological duality. The investment in supersonic technology not only aims at commercial aviation but also raises geopolitical concerns about potential military applications. The dual-use nature of this technology may seem contradictory to the commercial aspirations of companies like Comac in space transportation. While the public narrative focuses on reviving commercial supersonic travel, the underlying military implications complicate the perception of these advancements, suggesting that supersonic technology could significantly enhance military capabilities, which counters the notion that commercial and military aviation are entirely separate domains. 4. Emerging competition from China. The entry of China into the supersonic race is significant as it juxtaposes the traditional dominance of U.S. aerospace companies. This could lead to a perception that the U.S. is losing its edge in aviation technology. However, the counterintuitive reality is that by entering this competitive space, China may be inadvertently catalyzing further innovation within the U.S. industry as companies like Boom Supersonic and NASA ramp up their efforts to keep pace. The fear of competition could drive advancements that might not have occurred without this external pressure, thereby potentially leading to a faster evolution of supersonic technology overall. 5. Focus on mainstream viability over niche markets. The C949 aims for a broader market appeal compared to niche products from companies like Boom Supersonic, which is targeting specific segments of the supersonic market. This approach may seem counterintuitive, as one might expect new technologies to cater to luxury or high-end travel sectors initially. Instead, the C949's design for mainstream viability, targeting the potential for 45 million annual passengers, illustrates a strategic pivot towards making supersonic travel accessible to a wider audience, suggesting a belief in the normalization of supersonic travel in the future. 6. Innovations in aerodynamics and AI. The introduction of advanced aerodynamics such as the reverse camber fuselage and reliance on artificial intelligence for stability and control present a counterintuitive blend of traditional engineering and cutting-edge technology. Rather than merely improving existing designs, this approach indicates a fundamental rethinking of aircraft design for supersonic travel. This suggests that the future of aviation may not only rely on speed and efficiency but also on integrating advanced technologies to solve complex engineering challenges which may not have been previously considered essential in aircraft design. 7. Broader implications for global aviation. The revival of supersonic travel through initiatives like the C949 could challenge existing regulations that have historically limited overland supersonic flights due to noise concerns. The emphasis on reduced sonic booms indicates a potential shift in regulatory frameworks, which could open new markets and alter the competitive dynamics of global aviation. This counterintuitive outcome suggests that advancements in technology may lead to changes in policies that were previously seen as fixed, indicating a fluid relationship between technological innovation and regulatory environments. In summary, China's investment in supersonic technology reveals several counterintuitive trends that challenge conventional expectations about speed, capacity, market viability, and the interplay between commercial and military applications. These developments not only signify a resurgence in supersonic travel but also highlight the evolving landscape of global aviation technology in the face of new competitive dynamics. The report on China's $1.5 billion investment in supersonic technology, particularly the development of the C949 jet, reveals several significant aspects that may be overlooked by many readers. Highlighting these points is essential for understanding the broader implications of this initiative beyond just aviation technology. 1. Geopolitical implications of supersonic technology. China's foray into supersonic aviation is not merely a technological endeavor but also a strategic move in the context of global aviation competition. The fact that a state-owned entity like Comac is leading this initiative indicates that it is backed by government resources and strategic interests. This investment could enhance China's position as a major player in the global aerospace market, challenging the dominance of established companies like Boeing and Airbus. The dual-use potential of supersonic technology for military applications is another crucial point that often goes unnoticed. As countries develop faster and more advanced aircraft, the implications for military operations and capabilities become significant. The ability to transport troops and supplies rapidly can alter the balance of power in regional conflicts. This aspect raises concerns among nations, particularly in the context of existing tensions in the Asia-Pacific region, where rapid military mobilization could have serious consequences. 2. Environmental considerations and regulatory barriers. The strides made by the C949 in reducing noise pollution are noteworthy, aiming for sonic booms at approximately 89.3 decibels, much quieter than the Concorde's 105 decibels. This advancement addresses one of the primary regulatory barriers that have historically hampered the development of supersonic travel: the fear of noise complaints from communities near flight paths. Many readers might overlook the significance of this innovation in the context of environmental sustainability and regulatory compliance. The ability to conduct overland flights without facing severe restrictions could open up new routes and markets for airlines, thus transforming the commercial aviation landscape. It reflects a growing awareness within the industry about the need to balance technological advancements with environmental and community impacts. 3. Technological innovations beyond supersonic flight. The report mentions the incorporation of artificial intelligence (AI) in the C949's fly-by-wire system and its unique fuselage design to minimize drag and noise. While these features are impressive from an engineering standpoint, the integration of AI also signals a shift in how aircraft will be operated in the future. Many readers might not fully grasp the significance of AI in aviation. The potential for AI to enhance safety, efficiency, and operational flexibility could redefine pilot roles, aircraft maintenance, and even air traffic management. This shift could lead to a new era in aviation where human error is significantly reduced and operational costs are optimized. 4. Market potential and economic impact. The C949's design anticipates a demand for supersonic travel that could cater to up to 45 million passengers annually. This figure is crucial as it indicates a substantial market potential that could revitalize the aviation sector, particularly following the downturn caused by global events like the COVID-19 pandemic. However, the economic implications extend beyond just passenger transport. The development of the supersonic jet is likely to create jobs in engineering, manufacturing, and support services in China, thereby contributing to economic growth. The ripple effects on related industries such as tourism and international business could also be significant, fostering greater global connectivity. 5. Competition and innovation in the supersonic market. While the C949 is a significant development, it is vital to note that it is entering a competitive market with other players like Boom Supersonic and NASA's X-59. The emphasis on quieter and more efficient supersonic travel is driving innovation across the globe. This competitive landscape is important for fostering innovation. The race to develop superior technologies could lead to breakthroughs that benefit not only the aviation industry but also other sectors. The collaborative efforts among various nations and companies could result in technological advancements that have far-reaching applications beyond aviation. Conclusion. The report on China's investment in supersonic technology encapsulates a range of significant themes that extend far beyond the technical specifications of the C949 jet. The geopolitical, environmental, economic, and competitive dimensions of this initiative underscore its importance in the current global landscape. Understanding these nuances is crucial for grasping how such advancements could reshape the future of air travel and international relations in the coming decades. 1. Technological advancements in supersonic aviation. China's $1.5 billion investment in supersonic technology through the development of the C949 jet represents a significant leap in aviation engineering. This aircraft is designed to operate at Mach 1.6 with a range of 6,800 miles, surpassing the Concorde's capabilities. The innovative reverse camber fuselage reduces sonic booms to a quieter level, addressing previous regulatory barriers that hampered supersonic travel over land. The integration of artificial intelligence in the aircraft's fly-by-wire system is another cutting-edge feature aimed at enhancing aerodynamic stability. These technological advancements not only showcase China's engineering prowess but also reflect a shift towards sustainable and efficient air travel. 2. Geopolitical implications and global competition. China's foray into the supersonic aviation market has significant geopolitical implications, particularly in the context of rising tensions with the United States. The involvement of state-owned enterprises like Comac, which is under U.S. sanctions due to its ties with the military, raises concerns about the dual-use nature of this technology. The race for supremacy in supersonic travel, with competitors including American firms like Boom Supersonic and NASA's X-59, indicates a broader competition for technological leadership in aviation. This competition could influence international trade policies, military strategies, and global collaboration in aerospace research. 3. Market viability and passenger demand. The C949 is designed not just for technological showcase but also for commercial viability, targeting a potential market of 45 million annual supersonic passengers. This ambition is backed by a projected increase in demand for faster air travel as global air traffic rebounds post-pandemic. Unlike its predecessor, the Concorde, the C949 is engineered for mainstream adoption with a focus on trans-Pacific routes to minimize noise complaints. The commercial strategy reflects a keen understanding of market needs, positioning China to potentially dominate the revived supersonic travel market. 4. Environmental considerations in future of air travel. One of the critical challenges facing supersonic aviation is its environmental impact, particularly regarding noise pollution and fuel consumption. The C949's design aims to mitigate these issues significantly, with a noise level reduced to approximately 89.3 decibels. making it more acceptable for overland flights. This focus on reducing the environmental footprint aligns with global trends towards sustainability in aviation. As airlines and manufacturers grapple with stringent environmental regulations, China's advancements in creating a quieter, more efficient supersonic jet could set new standards for the industry and influence future developments in air travel technology. 1. The Concorde. Launched in 1969, the Concorde was a joint venture between British and French aerospace companies designed to revolutionize air travel by introducing supersonic passenger flights. Capable of reaching speeds up to Mach 2.2, the Concorde significantly reduced travel times for transatlantic flights, allowing passengers to travel from London to New York in under 3 hours. However, its operation was marred by high operational costs, limited range about 4,500 miles, and noise complaints due to sonic booms, leading to its retirement in 2003. 2. The Boeing 2707. This was an ambitious project initiated by Boeing in the 1960s to develop a supersonic transport SST aircraft as a competitor to the Concorde. The Boeing 2707 was designed to carry up to 300 passengers and fly at speeds of Mach 2.7. However, due to rising costs, environmental concerns, and regulatory challenges regarding noise pollution, the project was eventually cancelled in 1971. The Boeing 2707 became a symbol of the challenges faced in the pursuit of supersonic commercial aviation. 3. NASA's X-15 program. Conducted in the 1960s, the X-15 was a rocket-powered aircraft designed to explore the boundaries of flight, including speeds exceeding Mach 6. Although primarily a research program focused on hypersonic flight and space travel, the X-15 provided critical data that contributed to future aircraft design and understanding of supersonic aerodynamics. The program demonstrated the capabilities of aircraft at extreme speeds and altitudes, influencing both military and civilian aviation technologies. Future outlook: China's $1.5 billion investment in supersonic technology. China's ambitious $1.5 billion investment in supersonic aviation, exemplified by the development of the C949 jet, marks a pivotal moment in the aviation industry. As the country aims to surpass the speed record set by the Concorde, the implications of this investment extend beyond commercial aviation, touching upon geopolitics, technology, and environmental considerations. Here we explore the future outlook of this initiative and its potential impact over the next few decades. 1. Technological advancements in supersonic travel. The technological innovations driving the C949, such as the reverse camber fuselage to minimize sonic booms and an AI-powered fly-by-wire system, will likely set new standards in aviation design and engineering. As these technologies mature, they could lead to breakthroughs that transcend the realm of supersonic travel, influencing the design of conventional aircraft and improving overall efficiency across the aviation sector. By 2030, it is anticipated that the integration of AI and advanced materials will enable aircraft to be lighter, more fuel efficient, and capable of operating at higher altitudes and speeds. This could give rise to a new generation of jets that merge supersonic and hypersonic capabilities, potentially reducing travel times to mere hours for intercontinental flights. 2. Market dynamics and competition. China's entry into the supersonic market has intensified competition with established players like Boom Supersonic and emerging technologies from NASA and Lockheed Martin. By 2035, we can expect a more diversified market with multiple companies vying for dominance in the supersonic space. Collaborations and partnerships may emerge as companies seek to pool resources and expertise to overcome shared challenges, such as regulatory hurdles and technological barriers. The anticipated passenger demand for supersonic travel could reach 45 million annually by 2040, capturing approximately 1% of global air travel. This demand will stimulate further investment and innovation, prompting companies to offer differentiated products catering to various market segments, from luxury travel to more affordable options. 3. Environmental considerations and regulatory challenges. One of the most critical aspects of the C949 project is its focus on noise reduction and environmental impact. The aim to achieve sonic booms at 89.3 decibels is not just a technological feat but also a strategic move to address regulatory challenges that have historically hampered supersonic travel. By 2030, as environmental regulations become more stringent globally, technologies that mitigate noise and emissions will be essential for gaining regulatory approval. China's ability to balance technological advancement with environmental responsibility will be crucial. If successful, this could position the country as a leader in sustainable aviation practices, potentially influencing global standards and practices in the industry. 4. Geopolitical implications. China's ambitions in supersonic technology are not merely about commercial gain, they also carry significant geopolitical implications. The development of advanced aviation technology could enhance China's military capabilities, raising concerns among other nations, especially the United States. By 2035, these developments may lead to an arms race in aerospace technology, prompting nations to accelerate their own research and development efforts in military aviation. Moreover, as countries reassess their aerospace partnerships and supply chains, the geopolitical landscape could shift, with nations seeking closer ties with countries leading in aerospace innovation. This could create new alliances and tensions, impacting global trade and diplomatic relations. 5. Consumer acceptance and cultural shifts. As supersonic travel becomes more viable, consumer acceptance will be crucial. By 2025, early adopters may begin to embrace supersonic travel, particularly for business and luxury markets. However, by 2040, broader acceptance will depend on how effectively the industry addresses concerns about safety, environmental impact, and cost. Cultural shifts regarding travel may also emerge, with consumers placing a higher value on speed and efficiency, particularly in a post-pandemic world where time is increasingly seen as a precious commodity. This could lead to a renaissance in air travel, where supersonic jets become a preferred mode of transport for long-distance journeys. Conclusion. China's $1.5 billion investment in supersonic technology embodied by the C949 jet represents a significant step towards the future of aviation. The interplay of technological advancements, market dynamics, environmental considerations, geopolitical implications, and consumer acceptance will shape the landscape of air travel over the next few decades. If successful, this initiative could redefine not just how we travel, but also how nations interact in an increasingly interconnected world. As we look ahead, it is clear that the future of aviation is poised for dramatic transformation, with supersonic travel playing a central role in this evolution.